Hello and welcome to the Monday, March 24th, 2025 edition of the SANS Internet Storm Center's Stormcast. My name is Johannes Ulrich and today I'm recording from Jacksonville, Florida. Well, we got an interesting vulnerability to start out with, and actually I wrote a little bit a diary inspired by that vulnerability, but we'll cover diary and vulnerability sort of here in one. The vulnerability is in Next.js. Next.js is a framework built around React, and like so many of these frameworks, basically allows you to write a ton of JavaScript and backend components, all of it sort of nicely integrated. The problem here is how middleware plays into this. So in a modern web application, it's not just Next.js, it's, I think, particular, when you're looking at the cloud-based application, very common, where a request hardly ever goes directly to just one web server, but it's passing through various middleware components or proxies. These proxies, they can have a number of different functions. The simplest one is just caching, but then you have more complex things like rewriting headers or authentication. And authentication is the part that, of course, is specifically of interest to us. The interesting thing about having middleware take care of authentication is that it really sort of removes some of the dangers of implementing authentication from developers. The way this is usually implemented is that you design certain paths in the application as requiring authentication or authorization, and that is then being taken care of by a particular proxy. So the proxy knows, hey, if you are going to an admin page, then you have to be authenticated as an administrator. And it may actually then hand the request off to another piece of middleware that makes sure that you are the administrator. And these things often have caused problems. Same here for Next.js. So one issue with having this slew of different middleware boxes is that it's easy to get confused. Hey, did this request already go through a particular proxy? Next.js's solution here is to add a header that basically tells you, okay, this particular request went through these proxies, and it can be a list of them. And that's exactly where the problem happens here, where an attacker could just add a header that identifies that this request already went through the authorization proxy. So no need to check if this request is actually coming from administrator. We already verify that, and it is allowed to go to this particular URL to implement that particular function. So that's the problem here, that an attacker could spoof this header, and in doing so, and this header is called x-middleware-subrequest. So in doing so, the attacker can then bypass authorization. Interesting vulnerability, and like I said, not the first time that this kind of vulnerability has happened in these type of applications. That's sort of what inspired me a little bit with the diary about headers. I think I have to flesh this out a little bit. This was sort of written on short notice, but overall the problem is, well, of course, attackers can send headers. And you have to make sure that headers are verified, maybe digitally signed. Maybe initial proxies make sure that certain headers are not set as a particular request enters your bucket chain of middleware. And overall, don't make that middleware stuff too complex. I see this in particular with cloud-based application, where I call it sort of a little bit request inflation, where you have one request coming in, and like I said, instead of going straight to a web server and being responded, it goes through an API gateway that then sends requests to other APIs that themselves send requests to even more APIs. So very quickly with one little innocent request, you end up with dozens of sort of backend requests, which of course just increases your footprint, increases your attack surface, but also complexity, which hardly ever is good for security. Plus, of course, it sometimes leads to these very difficult to debug latency issues in applications like this. What should you do next? Well, of course, patch Next.js. Also, maybe review a little bit these proxy pipelines. There is an easy way to detect if you're running Next.js. It adds one of these X-powered by headers to HTTP responses. So that should be relatively easy to pick up. And according to an article on Bleeping Computer, there has been more and more abuse of Microsoft's trusted signing platform. This is something that Microsoft started offering last year. It costs you about $10 a month. And as a developer, if you signed up with the Microsoft Trusted Signing Platform, you can basically have your software easily digitally signed using a Microsoft-backed certificate. Now, to balance a little bit the security part here, they implemented a couple of protections. One is if you want to get the certificate on behalf of a company, the company has to be in business for 3 years, but you can also just get the certificate for your personal name, and then no real verification is happening. The other part is that these certificates are only valid for 3 days. So they're meant for basically short-lived development binaries that maybe you want to hand to a couple testers, and you don't want them to sort of be confused by certificate warnings. But of course, for a malware author, all of these barriers don't really mean much. Malware is changing all the time anyway. 3 days, after 3 days, probably it's getting recognized by some anti-malware, and as such, a 3-day valid certificate is actually quite appropriate for malware, and that's apparently how they're being used. Definitely something to be aware of if you are looking at suspect binaries. Double check how long the certificate is valid for. Don't just trust it because it uses a Microsoft verified certificate. Well, and that's it for today. So thanks for listening, and talk to you again tomorrow. Bye.